Hello everybody. Today we are going to look at an interesting data sufficiency problem. The problem reads as follows. A shelf contains hardcover and paperback books of either fiction or non-fiction. How many books are there on the shelf? Statement 1 says that 2/3 of the books are fiction and 1/4 are hardcover. And statement 2 says fewer than 30 books are paperback and more than 10 or non-fiction. As you could see from either of the statements, there's no overlap that we could use or exploit to our advantage. So we have to represent the information in a different format that would allow us to find a unique value of x that would help us answer this question. As with all GMAT questions, I'm listing down the possible options that would help us keep track of our interpretations and inferences. There it goes. So what we're asked to find is the total number of books that are on the shelf. So let us assume x to represent the total number of books on the shelf. You could also represent the different kinds of books with an alias. So let's say H for hardcover, P for paperback, F for fiction, and N for non-fiction. Good. So using these four variables, we need to find out the unique value of x that will help us answer this question. So let us look at statement 1. The easiest way to solving such problems is to capture the information in a tabular format. So let me draw the table. We have hardcover books, H, and paperbacks. Then we have fiction and non-fiction. The total number of books should sum up to x. From statement 1, we know that 2/3 of the books are fiction. So this column represents the number of books that are fictions. So 2x over 3. The total number of fictional books, both hardcover and paperback. In other words, if you have 2x over 3 represents the number of books that are fiction, then x minus 2x over 3 represents the number of non-fictional books. In other words, means that x over 3 represents the number of non-fiction books. And we also know that 1/4 of the total number of books are hardcover. So this row represents the number of hardcover books. So x over 4 represents the total number of hardcover books. Similarly, 3x over 4 represents the number of paperback books. How did we come to the value? X minus x over 4 gives us 3x over 4, which is the total number of paperback books. Looking at the information captured in this table, we still do not have any means to compute a unique value of x. So statement 1 alone is not sufficient, so we could basically eliminate answers A and D. However, looking at the denominators 3 and 4, we could easily infer that x has to be a multiple of 12. This is an inference that we could use at a later stage in our problem solving. Good. So moving on to statement 2, and redrawing the table. We have hardcover, paperback, fiction, non-fiction. Total number of books is x. We know that fewer than 30 of the books are paperback. So we have paperback row here. So total number of books that are paperback is less than 30. And more than 10 are non-fiction. The total number of non-fiction books are represented in this column. So the number of non-fiction books should exceed 10. Looking at this table, we still do not have any means to compute a unique value of x that would help us answer the problem. Why? because the number of paperback books could be anywhere between 1 and 29 inclusive, as well as the number of non-fiction books could be anywhere between 1 and 9 inclusive. So we have such broad ranges which does not allow us to compute a unique value of x. So option B alone, 2 alone is also not sufficient. However, when taking 1 and 2 together, we could see that there is a way by which we could compute a unique value of x. So let us look at both the tables together. So we know that the number of non-fiction books represented by x over 3 should be greater than 10. So number of non-fiction books should be greater than 10. The non-fiction books are represented by x over 3 should be greater than 10, or x should be greater than 13. Let us mark it as an inference A. Similarly, looking at number of paperback books, we know that the total number of paperback books has to be less than 30. Or in other words, 3x over 4 should be less than 30. Or in other words, x has to be less than 40. Let us mark this inference as B. Taking A and B together, we could rewrite x in a range. So x lies anywhere between 30 and 40. We also know from the inference 1 that x has to be a multiple of 12, and the only value of x that falls in this range and is a multiple of 12 is 36. Using both the statements together, we could compute a unique value of x that helps us answer the question. So the answer is C. Hope you enjoyed this video. Thank you.